Hello my dear students, a very warm welcome in today's session. So my students, we are going to continue our chapter number 9 in today's session, that was carbon and its compound, with the part number 2. In the previous lecture, we have covered the two types of the carbon's allotropes, that is the amorphous and the crystalline. And in the crystalline one, we have discussed about diamond. So before starting this session, we are going to revisit the previous topics. So in the previous lecture, we have studied the allotropes of carbon. The allotropes of carbon are those which have two types, that is the amorphous and the crystalline one. But what is allotropy and what are allotropes? You can see that the existence of an element in two or more forms in the same physical state is known as allotropy, and the different physical forms of the same element in the same physical state are called the allotropes of that particular element. Moving ahead, we have studied the allotropes of carbon, that is in the crystalline and amorphous form. So when we have talked about crystalline, the crystalline forms of carbon have regular shapes. They are diamond, graphite and fullerene. So crystalline form of carbon have the definite shape, as well as they have three types, that is diamond, fullerene and graphite. Okay, moving ahead, we have studied amorphous form of carbon. The amorphous forms of carbon do not have a regular shape, okay, and they are charcoal, lamp black, gas, carbon and coke. So these are the examples of amorphous form of carbon. Moving ahead, we have also studied the crystalline forms of carbon, that is in the detail. The three types are diamond, graphite and fullerene, and we have discussed about diamond, that what is the diamond, like formation of natural diamonds, like how are natural diamonds formed. We have studied in this that it is believed that diamonds were formed from carbon deep inside the earth under extreme heat and pressure. Okay, under the extreme heat and pressure, the natural diamonds are formed under the crust of earth. And we have also studied preparation of synthetic diamonds. So the preparation of synthetic diamonds is done by applying high temperature as well as extremely high pressure on the carbon. Okay, we have also studied the structure of diamond. As you can see here, that the structure of diamond is regular tetrahedron. But why? Because it consists of a carbon atom at the center and 4 carbon atoms at 4 corners. That's why it is regular tetrahedron, and we have also studied about this. Okay, moving ahead, we have also studied that as a result, a diamond crystal appears to be a closely packed three-dimensional rigid structure. Okay, the light that enters the crystal undergoes repeated reflections within the crystal before it emerges. Now, moving ahead, we have studied the properties of diamond, that is the nature, appearance, density and sparkling, electrical conductivity, transparency to X-rays and melting point. We have also considered about the effect of heat on diamond and chemical reactivity of diamond. Now, we have studied the uses of diamond also. Okay, the uses were in jewelry, in surgery, industry, etc. Now in today's session, we are going to continue with the second crystalline form of diamond. Now the next topic that we are going to study is the structure of graphite. So we are going to study the structure of graphite, that what is the structure of graphite, where are the carbon atoms located and in which form. Okay, structure of graphite. Graphite has a layered structure. Always remember that graphite has a layered structure. As you can see here, this is the first layer, this is the second layer and this is the third layer. Okay, but these all layers are made up by the help of hexagonal structures. These are hexagonal structures which are further made up of 6 carbon atoms. 1, 2, 3, 4, 5, 6. You can see clearly. So we can say that a layer is made up of by hexagonal structures, and that hexagonal structure is made up of by the 6 carbon atoms. Okay, and we can also consider here that these all layers are planar. Okay, these all layers are planar. That's why they can be shifted on each other. Okay, moving ahead, you can see it is written here also. It is made up of flat planar layers of carbon atoms. Each layer contains hexagonal rings consisting of 6 carbon atoms. As you know, a carbon atom has 4 electrons in its valence shell. We have already studied in the previous chapters of this class that the carbon atom has 4 electrons in its valence shell. What does it mean? That it has a combining capacity of 4 electron, which means that it can combine itself with the same atom of carbon or the other atoms of other elements. Okay, these electrons are called valence electrons. So the electrons that are in the valence or the outermost shell, those are known as valence electrons. So carbon has 4 number of valence electrons. Okay, you can take this screenshot. Moving ahead, we are going to study the reason for electrical conductivity. So basically graphite is a good conductor of electricity. But why? What is the reason behind that it can conduct electricity? We are going to study that. In graphite, each carbon atom is covalently linked to 3 carbon atoms. As you can see here, that if I am taking this carbon atom, this one, okay, this is linked to 3 carbon atoms. The first one is this one is the second, and this one is the third. But we know very well that it has a combining capacity of 4, right? So what does it mean? That it has an electron free in itself, right? So that's why the electron which is free at each carbon atom will be the source of conductivity of electricity. Okay, you can see here also that it is covalently linked to 3 carbon atoms rather than to 4, okay, leaving 4th valence electron of each carbon atom free. So it is leaving behind the 4th electron free, and this free electron accounts for the electrical conductivity of graphite, and that's why the free electron that is left behind, that accounts the conductivity of electrons, and that's why we can say that the graphite is a good conductor of electricity. Okay, I hope you understood this point. Take the screenshot. Now moving ahead, we have the next topic, that is reason for slippery nature. So why is graphite has a slippery nature? As we have studied during the first intro of graphite, that it has slippery nature. But why? You can see graphite contains layers of carbon atoms held together by weak forces of attraction. So this has layers of carbon atoms, 1, 2, 3, 4 and so on. Okay, this is a complete layered structure, and that's why they have some gap in between them, this, okay, and they have also a weak force of attraction between them, this force, and this force is known as van der Waals force. You will study these all types of forces in further classes, okay, but as you can see here, therefore the layers slide over each other easily, making graphite soft and slippery, and that's why these layers slide over each other because of the weak van der Waals force, and that's why make graphite soft and slippery. For this reason, graphite is used as a lubricant, and that's why we use graphite as a lubricant in our household uses or in machinery uses also. Okay, I hope you understood this topic also. Take the screenshot. Moving ahead, we have the next topic, that is properties of graphite. Now till now we have studied what is graphite, what is the structure of internal structure of graphite, where are carbon atoms located, what is the basic structure and the layered structure of graphite, and what are the reason behind electrical conductivity, what are the reason behind the slippery nature of graphite. Now we are going to study the properties of graphite. The first property is here, that is appearance of graphite. So how do graphite looks like? Okay, graphite is a grayish black opaque solid. We have studied this, that it's a grayish black opaque solid. What does the word opaque mean? It means that it cannot pass the light throughout it. Okay, it has a metallic luster, it has also a metallic shine, okay, and that's why we can say that it shines. Okay, next one is the nature of graphite. It is soft and slippery to touch. Whenever we are touching graphite, we will feel it's soft and slippery. But why? What is the reason behind its slippery nature? We have studied because of its layered structure of hexagonal rings of the carbon atoms. It is the layers slide over each other, and that's why it becomes slippery in nature. The next one is the density of graphite. Graphite has a density of 2.2 gram per centimeter cube. Okay, so this is the density of graphite, which is lower than that of diamond, and we have also studied that diamond has more density than this. That's why it has a lower density than diamond. Next one is electrical and thermal conductivity. Now what does it mean? That if graphite conduct electricity and heat or not. In the case of heat, we have studied that it conducts electricity because of the free electron that remains behind. Okay, and that's why it is a good conductor of heat and electricity. It also conducts heat because of the free electron present in it. Okay, next, the melting point of graphite. What is the melting point? It has a high melting point of 3700, that is 3700 degree Celsius. Okay, this is the melting point. You have to remember the density and the melting point of graphite. Take the screenshot. Moving ahead, we have the next property, that is effect of heat on graphite. As we have studied the effect of heat on diamond, that's why we have to study the effect of heat on graphite also. Now, when ignited in air at 700 degrees Celsius, whenever we are just doing the combustion of graphite or we are burning graphite above 700 degrees Celsius or at 700 degrees Celsius, graphite produces carbon dioxide. So, it will produce carbon dioxide. See, it is graphite. And in the presence of oxygen, when we are giving the heat, we are burning it, it will change itself into CO2 at 700 degrees Celsius. Please remember it, because this is the main point which you have to consider. Okay. Next property is chemical reactivity of graphite. So now we have to study if graphite reacts with solvents or the other elements or not. Okay. Graphite is insoluble in most solvents. So this is the first point that you can consider here, that it is insoluble in most of the solvents. Chemically, it is slightly more reactive than diamond. But when we talk about diamond, so in comparison, it is slightly more reactive than diamond. It can be converted into diamond at very high temperature and pressure. We can convert it into diamond at a very high temperature as well as pressure. We know it very well that when we just give a high temperature and extremely high pressure to a carbon substance, then it can be changed into diamond, that is synthetic diamond. Okay, take the screenshot. So till now, my students, we have studied that what is graphite in today's session. We have also studied that what is the reason behind electrical conductivity of graphite. We have studied that what is the reason behind the slippery nature of graphite. We have also discussed the structure of graphite. And as you can see that we have also studied the properties of graphite. Now what we have to study, the uses of graphite, that where graphite is used in our day-to-day life or in our regular activities. Okay, so moving ahead, we have the uses of graphite. So the first use, as you can see on your screen, is in making the lead of pencils. We have already studied this in the example of the graphite, that graphite is used in making the lead of pencils. Since graphite is soft and leaves a black mark on paper, because we have studied that graphite is soft as well as it leaves a black mark on paper, and that's why it is used to make pencil lead, which contains graphite mixed with clay. So in the pencil lead, we mix a graphite with clay and it leaves a black mark on the paper. That's why it is used as a lead in the pencil. Okay, moving ahead, the next use in the manufacture of electrodes. So what are electrodes? Electrodes are, you can see the structure is here of electrodes. Okay, these are the basically good conductors of electricity. Okay, these are used as cells in the basic structure of cells. These are used as the cathode and anode. Okay, and being a good conductor of electricity, graphite is used for making electrodes, and that's why, because we know very well that graphite is a good conductor of electricity, and that is why we are using it in the manufacture of electrodes for dry cells and electric arcs. In the dry cells, electrodes are used, and in the electric arcs, electrodes are used. Okay, you can take the screenshot of this again. The next use is in the manufacture of crucibles. So we also use graphite in the manufacture of crucibles. You can see the structure of crucible here, a crucible that is made of graphite. Okay, graphite is a good conductor of heat, is resistant to chemicals and has a high melting point. We have studied that it's a good conductor of heat as well as it is resistant to chemicals because its chemical reactivity is less. Okay, and has a high melting point also of around 3700 degrees Celsius. And because of all these properties, it is used to make crucibles for conducting high temperature chemical reactions and melting substances. And that's why it is used for making the crucibles in which there is chemical reactions that are conducted at high temperature and melting substances. It is also used for melting substances. Because of these all properties, we can use it in the manufacture of crucibles. The next use is used as a lubricant. Why we use it as a lubricant? Because it has a slippery nature, as we have studied. Because of the layers, hexagonal layers, planar layers that are present in the structure of graphite, we use it as a lubricant because the layers slide over each other, and because of the sliding they have a slippery nature. Okay, since graphite is soft and slippery, it is used as a lubricant in machineries. Okay, take the screenshot. So these are the other two uses of graphite. The fifth one is in nuclear reactors as a moderator. We also use graphite in the nuclear reactors as a moderator. Okay, graphite is used as a moderator in nuclear reactors to slow down the speed of fast neutrons. Why we use the moderator? What is the use of moderator in a nuclear reactor? Moderator are those substances which are used to slow down the reactions of neutrons. Okay, and that's why graphite is used as a moderator here. Next one is used to make black paint and printers ink, because it has a black color in nature. Okay, and that's why we use it as black paint and printers ink. Since graphite is black in color and insoluble in water, it is used to make black paint and printers ink. Okay, take the screenshot of this. To my students, we have covered the other crystalline form of carbon, that is graphite. Okay, in this lecture we have studied that what is graphite. Okay, and we have studied that what is the structure of graphite, and then we have studied the reason behind the electrical conductivity of graphite. After that, we have also discussed the slippery nature of graphite and what is the reason of the slippery nature. Okay, after that we have studied the properties of graphite, that is the appearance, nature, density, electrical and thermal conductivity, melting point, effect of heat, chemical reactivity. And after that we have studied the uses of graphite also, that is graphite is used in the making of lead of pencils, it is also used in the manufacture of electrodes, it is used in the manufacture of crucibles as a lubricant, and in the nuclear reactors as a moderator. It is also used to make black paint and printers ink. Now what you have to do, you have to revise this lecture. Till then, take care of yourself, enjoy your studies. In the next session, we are going to continue this chapter with the other crystalline form, and bye bye. Thank you so much.